Do any of you in here understand anything about gas lift at all? Have you been associated with it? Do you know how a gas lift valve works? Yeah. Do you? Yeah. You do know? Okay, you know how? Okay. Do the rest of you know anything about regulators, how a regulator works? In theory. Okay. Well, this is nothing but a gas regulator. This is a gas lift mandrel. This is run on your tubing string. Run it in a hole inside your casing. That's nothing but a 4-foot pup joint with 3 holes drilled in it with a lug welded on it that you can screw this valve onto. Now, the way this valve works, you have a nitrogen charge in what we call the dome here. Okay? You have to have something that senses differential pressure. That's the bellows that senses differential pressure. Then you got a stem and a seat and a ball. Okay, and you got a small seat here. It's like a 1/4-inch seat. In the bottom of it, you got a check valve. When this is made up in this mandrel and run into a well that needs gas lift, of course, the hole is cased. You got casing out here, tubing here. So your gas comes in through these ports here, right here in this gas lift valve, and it comes up around the area of this bellows. All right, now below this valve is closed. So you have tubing pressure coming under the seat of this. When those two forces, a combination of those forces, the force across the bellows and the force under the seat, excuse me, exceeds this dome pressure in here, then that valve opens. And that's, it's nothing but a gas regulator. All right. Valves are run, you'll never see one valve in the hole unless it's almost a dry well. Usually you'll have 10, 12, 14 valves in a hole. And the way that works, can everybody see this board? All right. This is I'm not an artist, but that's a rough rendition of graph paper. This would be your perforations down here. This would be your surface operating pressure, and this is what the pressure would be down hole. Gas is a liquid, it has weight, so you gain pressure as you go down hole. Well, when you run mandrels in this thing, gas lift mandrels, your graph paper is going to look something like this. Now these are drops in the pressures of the gas lift mandrel. If this top one's set at 800 pounds, this one be set at like 780. The reason for that is when you unload the fluid out of this well, then you get to this valve. If you had all those valves open, you couldn't operate because you wouldn't have enough gas to maintain it. So when you transfer to this valve, this 780 valve, that regulator, and that's all it is, that gas lift valve will drop this casing pressure to 780 pounds and it'll close this top valve. And that's the way it transfers down the hole. This valve would be set at 760, this one at 740. And you would transfer on down the hole as far as the well will let you transfer. You'll get to a point to where you will not be able to transfer in most wells to the bottom. And the reason for that is the pressure drop in the tubing. You understand what I'm talking about when I say pressure drop? Okay, the pressure drop in the tubing will not let you get that deep for the casing pressure you have. But most of these wells deplete, bottom hole pressures fall off, or they dry up. If it's a frac flowback or something like that, they dry up. So you need mandrels below where where your point of injection is for down the road to move on down. If you didn't have those mandrels, then when you needed to move down, you'd start blowing the gas around. You wouldn't, if you didn't have mandrels below your point of injection. Also, on a lot of wells, particularly on fracked wells, you pump a lot of water in them. And you have to unload that water before you start getting formation fluids. Okay? So you'll work deep unloading that well. This is your static, this is your drawdown. You know what drawdown is? The difference between your bottom hole pressure and what your well's going to flow at. You have to reduce the pressure at your well bore to make that well flow. So you're unloading heavy fluid, probably a 475 or maybe even a 5 gradient. So that's going to have a slope that looks something like this. So you'll unload past all these valves down to the bottom valve. Now that well starts making production, you're going to have gas, hopefully oil in it, and water. So that's going to increase your tubing pressure up the hole because the slope gets lighter. Starts looking something like this. So you've unloaded to here, but now it's going to work you back up the hole to where your point of injection here. So that's why normally we valve down to 50, 60 feet of the packer, just to be sure that if we need be, we can get down there. If anybody got any question, just holler. No questions, huh? Man, I'm doing a good job, Roy. All right, this simulator, let me explain what the simulator is. That's a scale model well. Got 2 3/8 tubing and 5.5 casing. It's got 3 gas lift valves in it. You got a valve at 1,300 feet, you got one at 1,990 feet, and you got one at 2,350 feet. And the top valve in this well is set at 550 pounds. The next valve is set at 500 pounds, and the next one's set at 450. And we have a 50-pound spread in this simulator, so you can watch the operating pressure of the valve on this simulated gauge. I doubt if you'll ever see a spread like that in a gas lift design because you lose too much horsepower. And the reason I say you lose too much horsepower, when you get to this valve here, then this is what your casing pressure would be. So if you had a 50-pound spread, it's going to be over here and over here and over here. So you probably couldn't get there because you don't have the pressure to get there. This valve is regulated this down to 750, and this one would be at 700. So when you want to transfer down the hole, you don't have the pressure to get down there. Your valves won't let you. So your valves are usually set with a 10 to 15-pound drop. Got some stuff for you here. Got some goodies for you, man. Got a calculator?
Yeah.
All right. You know some people in here? Can you share a book with them? Oh, you got it?
That's an extra one.
Okay, here you go. Now when I start unloading this simulator, if you watch this gauge, you'll see it, the pressure drop as you transfer down hole. This is your compressor discharge. This is your gas control into the casing. We call it an adjustable needle valve. It can be anything. It can be a metering valve, or it can be anything to inject the gas. And this would be your operating casing pressure here. These gauges, all they do is tell you what the tubing pressure is opposite these valves. You got 4 production gauges. You got a total gas, injected gas, formation gas, and formation fluids. And this is your wellhead pressure. So what I'm going to do, well, getting ahead of myself, the life of a gas lift valve is the way you unload the fluid through that valve. This well has a packer in it down here. So all this fluid is trapped in the casing. The only way it can get out of that casing is through these valves, through these little ports. So if you exceed 125 foot per minute second fluid flow through that port, then you're at erosional value. And if you leave it that way, you can cut that valve out in about 30 minutes. You won't know it. You'll have a leak there, you won't know it. And the reason you won't know it is because you'll go ahead and transfer down, because it's going to be a leak. It's not going to be a catastrophe, it's not going to be a failure. You'll unload, say, to the bottom valve. but this valve is leaking. So now you're injecting gas up here that you really want down there. The reason you don't know it is because you have no baseline to compare it to. You unload the well, it's making so much gas, so much fluid, at some tubing pressure and some casing pressure. But as time goes on, that can get worse, and I'll demonstrate that in the simulator. And if y'all got any questions or you want to ask anything when we're running this, just holler, raise your hand or whatever. Okay? All right. Forgot to tell you, API says you unload a gas lift well by increasing your casing pressure 50 pounds every 10 to 15 minutes till you get to 400 pounds. When you get to 400 pounds, then you can increase it 100 pounds every 10 to 15 minutes. Now, if this well is standing full of fluid to the tree here with a packer in there, and you've got 1,000 pounds line pressure, and you go over and put that 1,000 pounds line pressure on there, you've immediately created a 1,000 pound differential across those valves. And that's when it's dangerous. If it's like this well, where the 720 pound bottom hole pressure only hold a column of fluid this high, then it's going to take a while to fill this, to pressure it up. So if you start pressuring up your well and it's taking a while, you know you've got fluid down the hole. But you got to be careful until you get gas at the surface. And you will know you've cleared that top valve because during the unloading sequence, you're going to have solid fluid from that valve to the surface. When you get all the gas out of the casing down to that valve where you can inject gas, then you get gas at the surface, and you know you've cleared that valve. From there on, it's really uncommon to cut valves out from there on. It can be done. Offshore, if you've got a compressor sitting over there that's pumping 200 million, and all you have to do is open the valve, you can do it because you got the volume. Most of these wells down here, you got a 500,000 compressor maybe on location, or 3/4 compressor, and you can't get the volume once you unload that top valve. All right, here comes the gas. That's not gas lift, I didn't purge it. All right, see, I've got solid fluid all the way to the surface. And you won't get any gas, I still didn't purge it, till you get below that, get the fluid in the casing down below that valve. Okay, now we're injecting through the top valve. Okay, we'll continue to inject through this valve. The fluid's going through this valve into the tubing until we clear this valve, and then we'll start injecting this valve. Now when we do, this casing pressure is going to fall to the operating pressure of the second valve, which is 500 pounds. Okay, now we're at the second valve, and our casing pressure indicates it's at the second valve. Now, you might notice it's taking longer to get to the bottom valve. That's because as you go down hole, you're taking a bigger pressure drop. This is a gradient curve. You got this much gradient on the bottom, this much differential on the bottom valve. This one you got this much. So you have less differential to put fluid through that bottom valve, plus you have to, sorry about that class, plus you have to displace all the fluid out of here to that valve, and the well's making production, you have to handle that production from the second valve. So it takes a while to unload as you get deeper and deeper. We have one well up in Cleveland, Texas, It makes 2,800 barrels a day, and when it goes down, it will take a week or more to transfer to the bottom valve, simply because that well is making so much, and where the bottom valve is set, it's just almost at the point of equilibrium. So, and this wellhead pressure fluctuates. If you've ever been on a well, you'll see it doing this. Well, 1 minute you got no differential, and then you may have 10 pounds. So you have to put fluid from here to here, all the fluid through that bottom valve with very little differential, so it takes a long time to get down to that bottom valve. Anybody got any questions yet? Okay. Now when you get down there, hopefully you'll start seeing a little bit of that. That's your formation gas. All right, now we started producing from the formation. Okay, now when we designed these wells, we sent out an information sheet, and one of the things on that information sheet is wellhead pressure. And anything exerted on this wellhead, any pressure on this wellhead, you see right back on your formation. So that reduces your drawdown. It'll cut your rate. If we design a well for 150 pounds wellhead pressure and you got 200 pounds, we can probably make it work. But let's say it's 150 designed for, and you've got 250 pounds, you can have problems. Okay, now watch your formation fluids as I increase that back pressure to about 250. We're not producing anymore. All we're doing is blowing gas around. Okay. Now watch what happens as I continue to increase that pressure. Watch your bottom valve. Can anybody tell me what happened then? It's all differential. Instead of having this differential, you know what happened? It stopped. Well, that's a good answer, but why? Okay, what you've done, you've taken this curve where we were injecting and moved it over here where you don't have any differential at all. So you can't inject gas where you don't have differential. Now some wells you won't have packers in. You had something? Okay. Some wells you're not going to have packers in, and that can create a problem with gas lift in that you may not be able to optimize your gas lift without a packer. Let's see if I can demonstrate that. We're making 700 barrels, and I'm going to pull the packer out of it. Can you see what's happening? All right, our rate's already dropped to 500. Well, actually what's happening, you're feeding fluid in from the casing and the tubing simultaneously, and that valve can't handle it. So if you ran a well without a packer, you very well may get into that situation, and instead of making, what was I making a while ago, 700 barrels? Okay, you sit here and make 500 barrels until you had to work a well over the life of the well. Now, if the same thing can happen if you get communication below your point of injection. We're working on the valve, we get communication below the point of injection, then it can come up through the tube and into the casing and cover that valve. What will happen if you're producing your well, you're producing it, say, 450 pounds or so, and I've had operators come to me and say, I don't know what happened, my pressure jumped up and I lost production. Well, communication below the point of injection, you're feeding into the casing and the tubing simultaneously, and it's not optimized anymore. They got a pulling tool for that fixes it. It's called a RIG. You know what that is? The rig. Okay. Now I'm going to show you what happens if you cut a valve out. And the way I'm going to lower the pressure on this top valve until it starts leaking. Watch what happens at your bottom valve again. See, we're leaking now. And the gas we need there, we're injecting here. Our rate's going to fall off. Okay, we've lost 100 barrels so far. Now we've lost everything. All we're doing is blowing gas around. And that can happen because I've really never seen a leak heal itself. They tend to get worse, and you'd be surprised what we find in those valves too. We find gloves, pack of rubbers, pantyhose. We find, oh, it's true. They use, wireline uses pantyhose to look for leaks. They'll go in the hole they'll pressure up the tubing and go in the hole, and that pantyhose will go through the hole and grab their tool, and they can tell where the leak is. But they'll go through a leaking valve too. So that you never know what you're going to find in a well. Anybody got any questions on the simulator? Anything else you'd like to see? I mean, anything you'd like to see again, excuse me. Okay, now the fun starts. You want to open your book to page 58.